Bless you. So we know just for a regular function to be continuous, bless you, function is continuous, bless you, if all three conditions are satisfied. Okay. So first, remember it has to be defined at C. So f of C is defined. Okay. Second, the limit has to exist. Okay. And third, the limit of f of x as x approaches C has to equal f of C. Okay, so the existence of a finite gap somewhere in that function can make it discontinuous. So, for example, if you have, bring it up just a little bit. Say you have your x and you have your y. You have some left side of your function looking like that, and some right side looking like that. That little finite gap in the function is what causes it to be discontinuous. So we know that the limit of f of x, and that's your C, as x approaches C from the left, doesn't equal the limit of f of x as x approaches C from the right. Bring that up a little bit. Okay. So what we're going to do is we're going to find out how to find, let's say, where it's continuous. So if you have a piecewise function that is continuous all the way up to a certain point and discontinuous elsewhere, without having to graph it, because sometimes it's kind of complicated to try and graph all three and see where it's continuous. We have steps that are similar to these three up here, but just kind of tweaked a little bit, just to find out where they're continuous. Yes?
What's the other dot represent?
Oh, this is just if you have a piecewise function that goes to 0 and then it picks up another interval and then another interval. All right. Okay. Any other questions on this one? All right. Keep forgetting about it until we start talking.
Yeah, every time.
All right, so we have our steps for finding continuity in a piecewise function. Okay, so your first step is you're going to to find the limit of f of x as x approaches a from the left. And we're using a this time instead of c, and I'll show you why in a few minutes. And the limit of f of x as x approaches a to the right for every boundary point a. Oh. Okay. You want to also find f of a. Okay, so you want the limit from the left, the limit from the right, and you want to find f of a itself. Okay, so 2, you want to make sure that f of a exists. And third, you want to make sure the limit of f of x as x approaches a exists, which means both of those has to be equal. From the left and from the right have to be the same. And 4, you want to make sure the limit of f of x as x approaches a equals f of c. Okay. So really all the steps for our continuity. The only difference is with a piecewise function, you have to do it more than one time. With just a regular function, if you solve it once, you're done. Piecewise, you have to do it a couple of times. Okay, so if conditions 2, 3, and 4 are satisfied, then the piecewise function is continuous at x equals a. Okay, now a hint that will help you out, and I'll show you on the example what I mean by using the number line. Okay, so drawing a number line can help identify which f of x to use. Okay, because sometimes it can get a little bit tricky. Yes.
Number 4.
Mm-hmm.
Is that not supposed to be f of c? Is it supposed to be f of
Oh, f of a. Yep. Thank you.
They're like, we don't know what c is, so how do we know?
Yeah. After a while, you get used to writing f of c, f of c, f of c. Oh, I'll leave that up there for a minute till everyone's done. All right. Okay, so let's say, for example, we want to determine if f is discontinuous for any real numbers. And let's say if your f of x is equal to, say, x plus 1, if x is less than 2. F of x is equal to 3 if x is between 2 and 4. And f of x equals x squared minus 11 if x is greater than or equal to 4. And actually, for most of your problems, instead of x is greater than 4, you'll probably see it written as 4 is less than or equal to x, which is the same thing, but I didn't want you to see it and think it was done differently. Okay, so now your first thing you're going to do is you have to find a, because the whole problem kind of revolves around the value a. Which is your boundary point. Or it could be more than one, so it's possibly its boundary points. Okay, so to do that, we just have to focus there. So we have x is less than 2. You have 2 is less than or equal to x is less than 4. And we have 4 is less than or equal to x. Okay, so wherever it kind of jumps, those are your boundary points. So x equals 2 and x equals 4 are your boundary points. Okay. So what we have to do is we have to do steps 1 through 4 for both of those points. Okay, so you can kind of draw a little barrier there. So we can do x equals 2 on this side and x equals 4 on this side. Okay, so the first step, if you remember, we have to find the limit. Oh, forgot to do the number line. Actually, I'll do the number line right up here. And I'll try not to have it too cramped. Okay, so if you draw your number line and you put your boundary points, 2 and 4, when x is less than 2, your f of x is x plus 1. When f of x is between 2 and 4, when x is between 2 and 4, your f of x is 3. When x is greater than 4, your f of x is x squared minus 11. Okay, so that's kind of a hint to let you know which one to use, and I'll show you what I mean by that. Okay, so the limit of f of x, as x approaches, we're going to use 2 for now, 2 from the left. Okay, so if you look at your number line, if you're approaching 2 from the left, then your f of x is x plus 1. Okay, so now you just replace that f of x with x plus 1. So that's the limit of x plus 1 as x approaches 2 from the left.
I know you're going from the left just because it's less than, x is less than 2.
Yep, because when you're less than 2, you're approaching from the left side. Then if you're approaching from the right, it's going to be greater than 2. And that's why using the number line helps visualize it, because sometimes it'll get a little mixed up. Okay, so all we have to do is plug in our 2. So the limit equals 2 plus 1, which is just 3. Okay, so we know the limit of f of x as it approaches from the left is 3. Okay, so now we just have to find the limit as it approaches from the right. So the limit of f of x as x approaches 2 from the right. Okay, now if we look at our number line, we see as you get closer to 2 from the right, your f of x is 3. Okay, so now just replace f of x with 3. Oh, kind of separate that a little bit. Okay, it's equal to the limit of 3 as x approaches 2 from the right. And we know the limit of a constant is just that constant. So that's going to equal 3. Okay, so now we have to find f of a. Kind of separate that a little bit. So in this case, a is equal to 2. So to find f of 2, we have to look for our less than or equal to 2. Sometimes you'll see it up here. If that's less than or equal to 2, then that will be your f of x. But because this has the less than or equal to 2, you're going to use this as your f of x. Does that make sense? All right. Okay, so f of 2 is going to equal 3 just because that's your f of x. If it would have been the x plus 1, you would have had to plug in your 2 and you could have gone from there. Okay. So now we just have to make sure steps 2, 3, and 4 are all satisfied. Okay. So your second step, f of 2 exists. Okay, because it has a value there, it actually exists. Third step, the limit of f of x as x approaches 2, bring that up some, exists. And we know that because as it approaches from the left and right, those are the same numbers. So as long as they're the same from both sides, the limit exists. Okay, so we know that one's met and that one's met. So now the fourth one is the limit of f of x has to equal f of a, which it does. All three of these are equal. That's kind of the shortcut. If all three of these are equal, you can pretty much stop at step 1. But I'm just kind of going through the process. Because if all three of those are equal, then steps 2, 3, and 4 will automatically be satisfied. So for the fourth step, the limit of f of x as x approaches 2 equals f of 2, which is true because they both equals 3. Okay, so that's true. So when all of them are met, we know that it's continuous at x equals 2. Okay. So now we'll do the exact same thing for x equals 4. Okay. So our first step, we find the limit of f of x as x approaches 4 from the left. Okay. So you see here, as you're approaching 4 from the left, your f of x is 3. So that's the limit of 3 as x approaches 4 from the left, which is just 3. Okay. So now we have to find the limit of f of x as x approaches 4 from the right. Okay. So if you're approaching 4 from the right, this is your f of x. So that's the limit of x squared minus 11 as x approaches 4 from the right. So if we plug in our 4, we get 4 squared minus 11, which is 16 minus 11, which is 5. And to be honest, as soon as you see the limits aren't the same, you can just stop. Because we automatically know step 3 will be false. Because the limit won't exist, because they're not equal. So you can automatically stop if these two aren't the same. So the limit of f of x as x approaches 4 to the left doesn't equal the limit of f of x as x approaches 4 from the right. So that lets us know automatically it's discontinuous at 4. Oh, move that up some. All right. So any questions on that one? Yes.
Can you explain the second step on x equals 2? I just don't understand.
Mhm.
What do you mean by when f of 2 exists? It's just it's there on that line.
Oh yeah, it exists. So when we have f of 2, we had to pick where was x equal, well, less than or equal to 2. Yeah. So just by that value, that's the f of x we were using.
But it could have been 3, right?
What could have been
It could have
3?
been f of 3 because it's in between 2 and 4. Like x could have been 3.
Oh, x could have been 3, but that wasn't our a value. That wasn't our boundary value. So we're really revolving around the boundary values that we picked here. So those are where it kind of jumps.
I got you.
To make sense.
Yep.
So once you see where it jumps, that's really kind of your focus.
Could you move it down to 3 and 4?
Oh, sure. Sorry about that. There you go.
So we are saying f of 2 exists because it's before the boundary point of where we can say it's like f of 3 or whatnot?
Oh, no, yep. The only thing we're worried about are the boundary points. Because we already know they're continuous in between there.
Mm-hmm.
But the boundary points are where they kind of jump to a whole different function.
So if it was x squared minus 13,
Mm-hmm.
would it be continuous then, correct? Would it be 16 minus 13 would be 3?
Oh, if it was x squared minus 13, then it would have been continuous.
Okay.
Yep. Because then at least that part of it would have been correct. So we would have had to plug in f of 4, which would have been, oh, let me scroll down.
Isn't that anything with the, like, because it has the greater than or equal signs, or?
Mm-hmm.
Yeah. Like, does that have anything to do with it, with leaving a hole in the graph?
Which one?
All of them.
Oh, well, with this one,
Does it make a difference if it's like at equal to or greater? It has 2, like the number 2.
oh, let me,
I know it's kind of hard to, I'm trying to figure the words to explain it, but.
Trying
So
to
just because
figure
it's-
out. Oh, did you finish writing the other ones?
Yes.
Oh, okay. All right, what was your
So
question?
just because you have 3 different equations doesn't
Mhm.
mean that you're gonna have 3 different levels or spots where it breaks.
Exactly.
Right, so,
Yeah.
and I think this brings back to what he was thinking,
Mhm.
that's what I think he was thinking, was just because you have 3 different equations, there might be 3 different spots it breaks.
Okay.
And
Now
so-
it could be, but that's what we're
I
yeah,
said.
that's what we're
I said it
testing.
could be.
Was that what you were
But
asking?
because- But because they're equal
Mhm.
and the one spot,
Mhm.
that's not a break at all.
Exactly.
But, and then because that is not equal, that
Mhm.
is a break.
Yeah, exactly.
Okay.
All right. So,
Okay, yeah, that's, you explained it.
and actually, this is a graph of that one.
Okay, yeah, I see.
Yep. So you can see where it's continuous from all the way to x equals 2. And I'm trying to get the whole thing in there. Okay. Okay. So it's x plus 1 for x is less than 2. So this is the graph of x plus 1. Then once it hits 2, it becomes f of x equals 3. So there's no gap there, it just picks right on up, f of x equals 3. But then when you get to greater than 4, you see it kind of hops up here and start. So that's why it's discontinuous at 4, but it's continuous at 2. Yes.
On a test, are you going to ask the same questions like, look at this graph and tell me, is it continuous or discontinuous? Or
Probably not.
Okay.
Yeah.
You have us figure out the equation, that's the key. Try to find the equation for each spot.
And 9 times out of 10, they'll probably look like that.
Okay.
You have a question?
You were saying about finding your boundary points.
Mhm.
Let's say where it says 2 is less than or equal to x.
Mm-hmm.
If that was just a less than, then we wouldn't even have, that wouldn't be considered a boundary point, would it?
It would be, but
But
we.
then it'll make the first equation,
Yeah, but we'd
not exist.
automatically know it's not continuous. Yeah, unless it was greater than or equal to on the first one. I mean, less than or equal to on the first one. But one of them has to be equal to. If it's not
Or else-
equal to.
Or else pretty much at that second point, it'll be an open circle, right?
Yeah, exactly.
So back to his point,
Mhm.
if that did not, if neither of them had an equal sign,
Mhm.
but they were still both the same, on the same side,
Mhm.
it's not continuous because that open spot.
Yep, exactly. Yep. So if you would have had just 2 is less than x less than 4 instead of that less than or equal to, where that black dot is, it would just be an open circle. So as soon as you see no equal to's at all, you automatically know it's not continuous.
So
Because-
we wouldn't even have to do.
Oh no, you wouldn't have to do a thing. It's just automatically not continuous. All right, does that make sense?
So we only really have to do step 1, right?
Pretty much.
Okay.
Step 2 through 4 are really just kind of an explanation of step 1. So, but yeah, once you do step 1, find out, and if all 3 are equal, then you know step 2, 3, and 4 will actually
So
be
you would
covered.
have to do step 2, 3, 4 when it comes to a test.
Oh no, if you just do step 1 and find the limit from left to the right and f of a, and you just say all 3 are equal, so we know it's continuous. That's good enough. All right. Any other questions? All right. Put this. Okay, so let's say if we have. Oh, wrong way. There, put those there. So if we wanted to find the points where f of x is discontinuous, for, and let's say our f of x here is equal to negative 2x squared plus x plus 3, for x is less than or equal to negative 1. So if it's negative 2x plus 3, if x is between negative 1 and 0, and let's say if it's negative 2x squared minus 2 plus 3. Minus 2x, sorry about that. If x is greater than 0, or 0 is less than x.
So our boundary points would be 0 and negative 1.
Yep, it would be 0 and negative 1, or negative 1 and 0, depending on what order you want to go in. So we already know we have x is less than or equal to negative 1. We have negative 1 is less than x is less than or equal to 0. And we have 0 is less than x. So we already know that those are our boundary points. X equals negative 1 and x equals 0. Okay, so we go ahead and separate our page. We have x equals negative 1 on this side and x equals 0 on that side. And then we just do our steps.